Eric is here to tell us why we should say no more IPv4. Thank you, Eric.
Yeah, thank you. And thank you as well for this first talk on IPv6. Thanks to multiple people, including Andrew, Peters, and others, FOSDEM network has been IPv6 for many, many years. But networking part to moving over IPv6, and I'm from Cisco, right? So that's easy, kind of. The more complex part is the application, is the operation. So with this talk, I really would like to give you an idea what is the impact of not having IPv4 anymore, of moving to IPv6, and the last part will be whether it's worth moving to IPv6. Are there anybody besides FOSDEM using IPv6? So we all know, oh, by the way, if possible, I'm more than happy to take questions on the fly. I've got some giveaway for questions. Small stickers, you are too far away to see it, but it's basically IP legacy equipment only inside, right? It's basically for device running on IPv4. And as I'm a partisan of open source and open data, but also open book. With friends, we wrote a book about wireless. And the wireless is, of course, an IPv6 component, and I wrote the part. This is a book which is printed here as a giveaway, but you can find it as well on the internet for free, of course. So there is indeed no more IPv4. Right, you have it at home, but that's it. There are less and less IPv4 addresses available. It started 2 years ago, where IANA, the big pool of addresses in the US for the complete internet, ran out. Then after, quickly, it was APNIC, Asia-Pac, because they are simply growing. So they were burning and using the last IPv4 addresses before us. Us, assuming that most of us are coming from Europe, are basically for more than 2 years, basically. We are running out. Meaning a new ISP. If you want to create an internet service provider with friends, you go to RIPE to get addresses, and you will get a wonderful 1,000 addresses. Okay, if you want to be your ISP for your village, that's fine. If you want to be an ISP for your country or your province, good luck. Okay, so that's a real, real issue here. So basically, what are the service providers doing? Because, I mean, there is a wall, right? We need to go through this wall or bypass the wall. One way is what we call dual stack. That's basically where the service provider gives you IPv4, if it still has some IPv4 addresses, and a brand new protocol, brand new meaning 97. I guess, I mean, most of us in the room, right, are older than this. But I got sons that are younger than IPv6 and older as well. So it's not so young. Okay, so somehow the internet community has failed, honestly. And I mean, a couple of us are working in the IETF, which drives the standards and the deployment, and we failed to push it further. And anyway, so IPv4, IPv6 are there. There's one way of running them on the network, dual stack. Or second technical solution, which is the easiest one. And we all know that people, when they got a long-term fix, which is slightly more complex, or a short-term fix, which is easy, we take the short-term fix easy even if it's dirty. The short-term fix dirty, that's shared IPv4. That's basically doing NAT on the large scale. I shall come back on this. The third step is IPv6 only. So running the new protocol only, and accessing the IPv6 internet only, and accessing the IPv6 content only. Currently, it's a kind of a dream. Most operating systems can do it, not all applications, far less networks. And the content is not yet there. This network, with the name of IPv6 only, thanks to Andrew and the others, is not actually IPv6 only, because at the edge, as soon as you reach the internet, you can go back in IPv4. right? So it's not an IPv6 only, but it's already a good experiment. So most of the service provider will try to do dual stack. And I got 2 slides on this. On the left-hand side, assume that's your home, where you have on the left box your router and all the PCs which are there. Okay? And on the internet, you have IPv4. But now, the service provider is running out of IPv4 addresses. So you need to share, right? So that's easy. If you are receiving, you are 5 friends working late, and you order only 2 pizzas. If you have 2 big pizzas for 5 people, that's okay, right? If you cut it in enough pieces, everyone has got enough. Now, if you are 5 and you order a small pizza, that's where the problem is. Okay? Or else you go to the cellar or to the fridge and you get beers and the problem is fixed, right? And basically the beers, that's IPv6. I mean, kind of, right? It's Sunday after all. So, but basically here, we have an issue. We need to share. So the service provider is running out of resource, right? It doesn't have enough IP address. So it will share it. It will do the NAT in its network in big box. We call this carrier grade NAT. Carrier grade, it's simply because vendors like my employer can sell them for a lot of money. And others as well. Master is the same thing, right? We are even running Linux inside. And doing improved NAT, but anyway, that's NAT. Okay? So basically, you have an address here. It's translated once and twice. Wow. On this one, I'm pretty sure you can fix IP tables to do the right port forwarding to allow inbound connection, right, for your email server, your web server. Do you think the service provider will give you access to change the IP tables there? No, right? So we are in problem over there. It's basically called dual NAT. Now, if you add on the top of this dual stack, and that's what more and more service providers can do, because as you will see, if you are working only through this kind of NAT, it's not the internet as we know. The internet there is broken. They offer in green what I said, the beers, right? The green line is IPv6. And then there is no NAT at all, neither at the service provider nor at this box. Okay? Some people freak out because, hey, NAT means my security. Do you really want me to expose myself to the internet without security? I would say, haha, okay. If you rely on NAT for security, you're in bad shape. Different story. Everyone is behind the NAT, and most of the PCs, I mean, the one, not ours, right? But the one of our friends, mothers, father, and blah, blah, all of them has got viruses and are part of a botnet behind the NAT. A clear statement that a NAT does not protect you. But here, you don't have any NAT. And a lot of advantages we shall see. So, meaning that every content provider now needs to prepare itself to a world where, or application, right, where inbound connection to your application, to your content, can be like before, a single public IPv4 address per everyone, or a shared IPv4, or a mix of IPv4 and IPv6. Right? Multiple solutions, but you must be ready for them, your application, your servers. So we all know that there are only 65,000 TCP ports, right? And if the NAT is kind of naive and efficient, it means that per IPv4 address that is shared by the service provider, it can have only 65,000 connections, right? 2 to the power of 16. Now, if he's sharing this IP address by 1,000 subscribers, a couple of streets in downtown, it means that every subscriber has only 60 connections. I am a father of 2. I think we have 3 Androids, 1 Android tablets, 1 iPad. Everyone has got a laptop with a couple of devices. It's not enough, okay? I have a Jabber session open, I have Facebook open and refreshing every time. I need way more session. And we all know that Ajax relies on other session. Example coming from Japan. I mean, actually, it is the map of Brussels downtown. And you know, with Ajax, we are downloading tiles on Google Maps. Just using it as a visible example. If you are running out of connection when you create a new Ajax request or object, you cannot get a tile, and the map is empty. So on the map, you see it. Now, what if it's a game? What if it's an e-banking application when you only get part of the information? Your application, at least, must support that when it tries to get and open a connection to Ajax, it can fail. Okay, gracefully fail and display a warning there. Now, questions for you. I'm not sure whether you know what Speedy is. Who knows Speedy? Okay, so for the other half, right? Speedy is basically a TLS connection where you multiplex HTTP requests on the top of it. So all the Ajax connection of before on the background map will go over a single TCP TLS session. Okay, so you will not exhibit this behavior. But at some point of time, it will fail anyway. You can simply open more tabs, more browser window, and that's it. Reputation now. And I don't know how much of you are working into the spam world. But to oversimplify, if you receive an SMTP connection to sending an email coming out of some countries, and again, just to take the obvious, like Nigeria, right, you may suspect it's coming out of spam. And some very specific IP addresses are reputed as spam because they are open relays, for instance, right, or they're part of a botnet. You do it per IPv4 address, public. Now, if your host is beyond this big carrier grade NAT, you are, the bad guy is there with 1,000 at a good guy. It brings the reputation of the shared IPv4 address, the one used by these 1,001 people, when they go to the internet, as bad. Okay? So your good email could be marked as spam, not good. Or vice versa. The spam could be categorized as ham, as good. Not good. How do you protect any server, in this case a web server, against user trying to do a DOS against you? Such as sending your request to your content management system for search. How many search can you sustain per second on your server? Maybe 100, because it involves a couple of SQL behind it. Now, what if one guy is sending you 1,000 search requests per second? Normally, you look into your log and you block this IPv4 address, right? So now, there's the issue of reputation again. If there is one bad guy behind the CGN launching this 1,000 search per second, you block it, you block the other customers sharing the same IPv4 address. So you need to find something else. If it's web, you can use cookies, for instance, right? Or this is the case where a friend of mine, Ed, he was using his mobile phone and searching on Google simply. Google obviously needs to protect against those attacks. But what Google didn't know, it was mobile phone beyond the CGN. And there were mostly 100 or 200 people beyond the CGN doing the search at the same time. So there it was good behaviors of everyone, but it was tagged as an attack and blocked. Hence the CAPTCHA, basically, to prove that you are a human. And the other part, I mean, all applications, most of them are good, well written, but they will be attacked at some point of time. If your application has some value, it will be attacked. And in some cases, you want first, of course, to make an application more secure. But in some cases, you may want to trace back to see who is attacking you. It becomes much, much more complex, right? Because an IP address doesn't mean anything. Service providers now need to keep the logs of the translation, saying, hey, this subscriber at that specific period of time used that IP address, as they do right now, and this TCP ports. Meaning now, in all your logs, even if you don't want to go to the IPv6 route, in all your logs, for whatever application you need, if you are logging the remote IP address, you also need to log accurate time and ports, the remote ports, TCP or UDP. So in case of incident, we can trace it back to the source of the attacker. And that's basically what I'm explaining on this slide. If your application uses Apache, that's basically one way how you can configure Apache to log the ports. And that's basically in red what's happening here. So a friend from Yahoo ran this. Maybe you have seen this. That's a big thing. It's a CGN, and you see it's 100% loaded. And basically it means that on the left-hand side, you have multiple IP address, multiple subscriber, but they appear to the internet as a single one. And by the way, you are also losing your geolocation there. So if you look there, you see C, like Seattle, SGC, they are airport codes, right? Like San Jose, Oak, like Oakland. And you see as well here, bad guy, like the bad guy. And this bad guy misbehave. And that's what I've explained. What are you left to? Cutting everyone. That's basically the internet that we are heading to. Okay? It's not the internet we knew 3 years ago, 5 years ago. If you want to keep the internet we knew 3 or 5 years ago, we need to get the move and move to IPv6. So let's talk about it. Okay, I tried to summarize IPv6 in one slide. So one thing is basically the same thing. It's like IPv4 with much larger addresses. Such thing like 128 bits rather than 32, okay, of unit will have impact. There is no NAT, okay? I already explained it doesn't bring anything against security. It even makes things simpler, right? Because there is no NAT, less configuration. Everything which is simple is always more secure than something which is more complex. So it's security. Data link layer, no need to change. Your Ethernet, your Wi-Fi will run unchanged. The transport layer, the socket API that you are using for TCP or UDP or whatever, no change. Application themselves are unchanged. And I put quote, because I'm spending the rest of my talk explaining what are the change. But basically, postfix, DNS, whatever you want, are running perfectly fine over TCP. The protocol is unchanged. So basically, it's IPv4. It's neither better nor more secure. There's been specified, as I said, a long time ago. Everything is pretty much identical, including IP security or SSL. They work the same. The only benefit, honestly, is the big address space. And the benefit of the big address space, as I said, we get back the internet we had 5 years ago. And I think it's important. 128 bits, that's a long, long, long number. The only way to do it is to write them in hexadecimal. Right? Everyone hates hexadecimal. And you will have to explain shortly to your daughter, or to your girlfriend, to your boyfriend, or whatever, how to spell an hexadecimal address. Okay, it was already difficult with an IPv4 address, even more. We simply block them, group them by 4 digits. Okay, block of 32 bits if you do the math. And there are multiple ways of writing it. There are, of course, letters like A, B, C, D, E, F that you can write in lowercase and uppercase. Oh, so now you need to be search insensitive in your text file or whatever. And we are also removing zeros, okay? Because hidden zeros are useless. And multiple block of zeros can be suppressed and replaced by a single colon, colon 1. Okay? Could even be if you have this address in IPv6, which is the equivalent of the 127.0.0.1, the loopback address, right? LO0. You replace all those blocks of zeros by colon, colon. And you have this address, which is colon, colon 1. Okay. So you see geeks now having T-shirt, there is no such place as colon, colon 1. Right? That's nice T-shirt. This one, with all the zeros, which is used mainly for default route, on the v6 address, when you do not know yet your IP address, is full of zeros, is written colon, colon. I mean, I'm used to it, but the first time you need to scratch your head. Because if you see in an error message, your address is colon, colon, you look, hey, where is my address, right? But it's there. Of course, then, with such numbers, you really, really need to get DNS working. And DNS has two ways with IPv6. Okay? You have, in the IPv4, you get the A to translate the host name to IP address, and you get the reverse mapping, what they call the PTR records, to translate an IPv4 address into a name. In v6, we've got the same thing, of course, because we need to do the same function. And we have there the quad A to translate a name into an IPv6 address. Now, if you wonder why a quad A, that's simple. A was for an IPv4 address, 32 bits. So quad A is for 4 times longer addresses, 128 bits, like IPv6. And that's the real story. Now, the reverse is, of course, you need to spell out all the numbers. It's mostly impossible to do it by hand. Okay? You need to get tools for doing it. And the last point with DNS, in the case of DNS, you need to transport the DNS request. You can do it over IPv4 or IPv6. It's orthogonal, right? You can send a request for an IPv6 address over an IPv4 UDP or over an IPv6 UDP and vice versa. What you request over DNS has no link with the transport mechanism. Could be completely divergent. Readiness. Are we able to do it? Yes, for many, many years. Okay, routers, switches, PCs, OS, whatever you want. Everyone is ready. Application, Microsoft, macOS are, and of course, for many times longer, the Linux and the BSD are as well. Okay? So there's not so much an issue on the operating system or on some application. A lot of application, specifically in the public domain open source, are dual stack for many, many years. I don't remember when Apache got v6 support, but I'm running an Apache server over IPv6 since 2005, right? And it was IPv6. So it tells you how much the open source community was in advance there. Coexistence, quickly. And you need to understand a few things. And for instance, there's a reason why we need to talk about DNS. I have a dual stack PC on the left. And I have any kind of servers, take it web, that could be whatever you want. I put IPv4 internet and IPv6 internet over there, like two clouds. But actually they are the same, of course, right? There's the same routers, the same optical fiber, the Wi-Fi, whatever, there's the same. But it's easier to show here on the slide. Now, if the PC wants to visit, let's say, a server foo.com, he asks to its DNS server, hey, what are the v4 and the v6 addresses to request, by the way. And in this case, the server will reply, hey, here are the two addresses, one v4, one v6. Then it's up to the PC, and that's maybe what looks slightly surprising. It's up to the client, to the initiator, to decide whether to use IPv4 or to use IPv6. It's not up to the application on the right-hand side. It's not up to the server on the right-hand side to decide. Okay? Then it will go one way or the other way. Not easy at all. The decision is done by the initiator. Two ways of doing it. There is some kind of local policy within the operating system of the initiator that say, hey, here the set of my addresses, v4 and v6. Here are the set of IP addresses, v4 and v6, of the server. Which one should I use? And let's say the internet has tried to make a good decision there. Or you are more pragmatic and you rely on the stuff written by Dan Wing and Andrew. Andrew being the guy with the curly hair and the yellow t-shirt in the front there, right? Which is API eyeball. Eyeball being this in English, right? And you want to keep the user of the application happy. And how you do it? By ensuring that you start connection v6 first, you wait a little, and you open IPv4 connection. And then you use the fastest one, summarizing. Okay? So if v6 is faster, you get v6. If v4 is faster, you take v4. If both of them are mostly equal, typically you go over v6. So far, so cool. To my understanding, only Chromium implements this RFC to the letter. Without any big surprise, Windows and OS 6 do something different. So now, I mean, it's kind of laughable, right? It means the application on the right-hand side needs to understand those three different behaviors and be ready for them. And you don't know it, because when you start, you receive the TCP SYN, you don't know, right? There is no user agent string there. It's way later that you get the user agent string. So content have no influence there. So what you can do as well is using something called NAT64, and it's basically what the Wi-Fi team is using here, where basically you ask the address of the server. If you get v6, you go direct v6. Else, you go to a specific box called NAT64. It's nothing from IPv6 to IPv4. As I said, the application are unchanged. It's still HTTP, HTML, and blah, 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 blah. So you simply need to change the network layer, IPv4 addresses to IPv6 addresses, and shuffle a bit in some field, and you're gone. Easy. You can do it as well on the server side. So in this case, in this case, I have IPv4 only servers, and I'm using, let's say, some kind of HTTP proxy, mainly for SSL acceleration or web caching or whatever. So the people coming from the IPv4 internet go traverse on your DMZ, maybe a firewall, but arrive at the reverse proxy, okay, via HA proxy or whatever, before going to the IPv4 server. All those proxies, they're application proxies, so they can receive a connection over IPv6 on the left-hand side, do the proxy at the application layer, and connect back to IPv4. So if you know how to deploy a proxy in HA, proxy, or Varnish, or whatever, it's trivial to move your content, your application, to IPv6. So little excuse not to doing it. OK, anyway, the crux. Impact on the application. Multiple things. We shall see whether the package is there or not. That's basically the agenda of the next slide. As I said before, a lot of applications are ready for IPv6. I put, for instance, it's very complex in bind. You need to type this command. On SSH, you need to be sure that you listen to address colon, colon. Again, remember, colon, colon means full of zeros, meaning any addresses, basically. Okay, so don't be surprised, that's the way it's written. And in postfix, you need to say added protocols equal all. So very, very simple to configure. Are there any IPv6 only networks? There is this one here. There is Cernet, which is basically the education network in China, and a few others, including, and I think it's important, T-Mobile in US, which is a mobile provider for the 4G network. They are using Android phones with only IPv6. So it means that, of course, as the user still needs to go to some legacy IPv4 content, they obviously need to go through a NAT64 box. We started with a couple of IPv6 enthusiastic, an IPv6 only day. Okay? So we signed a petition, and we are, I don't know, 200 now or something. Feel free to join. And we said to our employer, on that day, I'll remove IPv4 from my laptop. Either you give me the tools to work, or simply I do whatever work I can do with v6. Okay? So now it will be kind of challenging. It's a Friday, if not mistaken, so that's always a little bit easier. See the link over there. And in the same vein, and I just hear about it last week, BSD 10.0 is a specific build without INET protocol family, only INET 6. So you install it, and you get only IPv6. That's a little bit extreme, of course, right? But if we do not try, if we do not push, the world is not changing. Okay, so we need to keep hammering this. So one technical thing that you need to understand as well on the application, at the application layer, right? If you have a socket for TCP or UDP, you can send whatever size of segment of message. You can write 10K, and for you it looks like it's atomic, but as you know, over the Ethernet, it's limited to 1,500 bytes. So it's chunked in small pieces. Fair enough. Now, some links are smaller than others, hence the need for something we call path MTU. MTU meaning maximum transmit unit. So a way to discover the shortest packet on the path between the client and the server. Okay? In IPv4 it exists. In IPv6 as well. In IPv4, if it does not work, not a big deal. Because routers on the path, when you receive a big packet and need to send to something which is smaller packets, it will fragment it. IPv4 is working fine. In IPv6, in 97, they wanted to optimize the routers and basically say, routers in v6 receive a big packet. On the other side, small packets, I'll drop the packet. Period, right? Meaning that now, this path CM2 discovery that works by kind of magic, actually ICMP packets, right? To discover the smallest packet size on the path must work. Now, implementation is broken. Some security people are stupid, right? It does not work. So we need to change this. And one easy way of doing it, that's by doing an option when you open a TCP socket to set what we call the MSS, the maximum segment size. So the maximum segment that you are ready to receive over TCP to something which is small enough so you are sure it will go on every line. And that's the value which is there. So it's commonly used by big content provider right now, simply because they don't rely on path CM2 discovery to work. v6, no more NAT. And I think that's the best things. Okay? We are now open to a real peer-to-peer communication, whether it's BitTorrent or real phone or video, whatever. Now, every time you place a phone call, a SIP call, or whatever, you are behind the NAT. You cannot really traverse it. you always go to somewhere in the cloud to act as a relay, right? If you're using Skype, for instance, bingo, the relays are in Microsoft. Do you want to place your call going through Microsoft in the US? It's up to you, right? But with NAT, you had no choice but using relays. In IPv6, there is no NAT. So if the gentleman there wants to talk to the gentleman over there, they go direct without going through a third party. That's wonderful. And to come back on Microsoft, right? At least for once they were, they've been smart multiple times. But something where they're pretty smart regarding V6, their new Xbox relies on V6 simply because they want to go direct for gamers. It's always shorter if you go direct than if you go by a third party. There's a reason why they want to support, they do support V6. Also, NAT, if you have an application doing NAT, okay, and using TCP, NAT device need to keep states, need to remember, hey, this address and this port talks to this address and this port. And of course, it's memory. If there is no traffic, they remove it. So your application right now needs to send keep alive over TCP, right? Every few minutes, simply to keep this state in the NAT device up, prevent it to be being removed. Now in IPv6, there is no NAT, so there is no need to send those keep alive. And we made some experiment in a different framework about the battery life of a mobile phone, whether you are keep alive and sending radios. It changed a lot, dramatically, if you want to send keep alive quite often, or you don't send keep alive, because you don't need to try to maintain state in your NAT IPv4. So really important. Now, when writing application, you need to be aware that the IPv6 addresses are much bigger. Okay, looks obvious. So you need to have a screen which allows the input and the output of V6 addresses. Same for the configuration file. If you store it in a SQL database, you need bigger field. Your lock need to understand it. Looks easy. But I was talking once to a developer of application, you know, on this small payment terminal you get in shops. When you put your credit cards or MasterCards, they do not have, an IPv6 address is maximum 39 characters. The width of the screen is 20. Okay, you can tell me, it's easy, right? We can write it on 2 lines. After all, I mean, we tried it, don't we? The keyboard now. How many keyboards have you seen on those machines? Hexadecimal. Right? None of them. It's 0 to 9. There is no A, B, C, D, F. Okay, now we can again, right, like SMS, right? Press twice to the 0 and you get A. Press 3 times to the 0, you get B or whatever. Not that easy. I would love to draw your attention to those 2 functions in blue. Because as I said, V6 addresses can be written in multiple ways, right? Lowercase, uppercase, with leading 0, without leading 0, so whatever. There is one single way to write it into a canonical format. And those 2 functions basically transfer from the printed ASCII to the network, binary, and vice versa in the right way. So that when you display any V6 addresses, please display it into the right way. So the same thing for the audit, of course. Socket API. If you want to use this, couple of function has been made dual stack. Okay, you can use, for instance, this one rather than there's a socket, because this one has wider space for V4 and V6 or whatever later. You may as well now either open 2 sockets and do the select, the loop on the select on the 2, one which is V4, one which is V6, which is quite a lot of applications are doing, or you use a single one, the one for IPv6. SSH, my understanding, is doing this, OpenSSH. And then we can add, hey, what if I want to connect to IPv4 it's OK. Your IPv4 connection coming from the outside will arrive and will be mapped into this kind of very specific v6 address, where at the last part is the v4 address. By 22 bits of IPv4, you can include them into an IPv6 address space. The other way is impossible. There's a reason why they're done this way. Now, if you program in Perl, Python, or whatever, you don't care. Because usually you open a connection to a DNS name. And it's up to the libraries to do the magic. Work over v4 or v6. That's where basically API ball can work. But we have seen that API ball depends somehow upon the underlying operating system as well. This RFC 6424, and you see the table on the right, it looks pretty ugly. I always need myself to reread the draft, the RFC to understand what it means. But it basically means, hey, if I have a loopback address, I use it. The higher the precedence, the better. I will not go in detail. But it's basically what Linux and other operating system has by default. And you can change it locally. So if your application is doing the right system call and library call, it will be processed by this library, at this table. OK. Are you losing your time this afternoon or not? Is there any IPv6 on the outside? First, I will encourage you to use this IPv4, which is you install it on Chrome, or there are variations for depending upon the browser. And it displays here, this page has only been received on IPv4, the big 4. In red, of course, right? If it's in 6, this is in green, right, as usual, and others. So you can really see what's happening. I really encourage you to see it because you see more and more. I mean, all the YouTube, the Gmail, the Yahoo, the Wikipedia, and so on, and Facebook are over v6. So a huge amount of websites are over v6. OK. How can we measure? And that's basically what I'm spending a lot of my time here. One way to measuring it is to measure the subscribers. How can we measure home users? We rely simply on big websites. And the biggest one doing it publicly is Google. And basically, what they do, they insert a 1x1 pixels, outside of the frame with a negative positioning, so you don't see it if it fails or whatever. And the pixel, you basically are fetching 3 of them. One which is on an IPv4 only server, one which is an IPv6 only server, and one which is on the dual stack, right? And you add basically a random number behind. So now, if the user fetch the v4 and the v6, is dual stack. If he fetch only the IPv4, it's single stack v4. If he fetch only the v6 image, it's on the v6 only network. Very simple. And you can get statistics on this. I shall come back on other mechanisms there. That's basically what I said on the 1x1 pixel. So what does it give? Those are the public numbers from Google. And they are quite nice. They are also, in some point, very much open data. And async sharing data is very, very important here. So in green, this is basically the numbers of browsers having IPv6. And it's growing. We are currently slightly below 3%. It's doubling every 9 months. Cannot resist. I'm from Belgium, right? And usually, my country is assumed to be a laggard, specifically in IT, compared to Netherlands, Germany, or whatever. And again, thanks to the numbers from Google, I'm simply doing some number crunching there. And if you look about the purple one, this is Belgium, where we have just slightly 9% of the users. Switzerland, which is on the top, is around 10. There are variation simply due to the vacation or whatever. So if you do an application which is v6, it's not for the beauty, that's because there are users behind. And you can also monitor the web content. And how do you monitor the web content? You simply download, again, an open data source of the 1 million most visited websites. And through a Perl script of mine, you try to reach all of them. And if you reach over v6, lucky. And it gives you something like either those curves, where you see going up and up. This one, this date was June 2 years ago, the World v6 launch, where the big websites all jumped together and enabled v6. They didn't dare to do it like this, alone. So they do it for 1 day in June 2011. Right, that's why you see a big peak here. And then they do it for 24 hours, just a test. If we put this on a map, and you can see it on the website on 6lab, you see the Czech Republic and Luxembourg are the best one. A lot of green, okay? And that's good. Okay? So again, the big websites are very important here. BitTorrent. BitTorrent supports v6 for many, many, many years. Okay? And BitTorrent and NAT are not friends. So you can guess that BitTorrent and IPv6 are good friends. So I wrote a BitTorrent client using the libtorrent library and basically pretend to be a BitTorrent peer and trying to download as much file as possible. I was not downloading them, and I was not having them, right? If by any chance there is a police in the room, right? I've done nothing bad, I hope. And then I can measure them. And again, you see a lot of greens. Right? The greener, the better. And the country, I think it was Germany, with the most peer doing v6. So my website, my client, in January, about 60% of my German peer were IPv6, and 40 were IPv4. Bias, of course, right? Because IPv4 they are behind the NAT, and I cannot reach them. Okay, they only can reach me. So the numbers need to be taken between with some precaution here. Okay, with this, I think I'm mostly just on time. We have mostly time for 1 or 2 questions or more after. And don't forget, if you have questions, you can book your stickers. Now, if the question is bad, you have nothing, right?
Good afternoon. What do you think about NAT66?
Okay, there is the question is about NAT66. Okay, can we do NAT from IPv6 to IPv6? Then the question is twofold. The ITF has standardized an IPv6 network to another IPv6 network. It's mainly for multi-homing and this kind of stuff. But the ITF has not standardized something like a complete IPv6 network to a single IPv6 address. So there is no NAT66 like the sense of NAT in IPv4 on purpose. Now, to be honest, customers ask it. So vendors like my employer and others do it. But it's not standardized. Okay, and it's bad. It's bad. Okay? Okay, I need to get my salary paid, right? So I'm okay with it. So grab a book afterwards.
How do I get my internet provider to give me IPv6?
Okay, how to push your your ISP provider to get IPv6? So first, if you want to try, and that's what I've been doing, there are multiple what we call tunnels provider, like Hurricane Electric or 6XS. Okay, look for tunnel brokers, you'll find it. Basically, you install something on your Linux box, and then all your network at home or at office goes through your Linux, put all the v6 packets into an IPv4 packets, it's sent. Working fine. It works for me for many years. How to push your service provider? Maybe it is. I mean, from your accent, I guess you are from Germany. Austria, no luck. Yeah, sorry. Austria is not that advanced. No, asking, and asking, yeah. Another book for you if you want.
Can I?
Or and you drop the stickers, right, with IPv4 only for your provider.
Okay, sir.
Can I?
Sir, you said Japan has already run out. And how are they approaching it? Are they
V6 only, or are they dual stack
Which
with
one?
M80 or something?
This?
Japan. They run out, you said.
Yeah, on BitTorrent or?
No, Japan itself. How do they give out the IP addresses?
With the servers?
What's the clients?
The client. BitTorrent, right?
No, just IP. How do you connect NAS?
Let's do it offline. Anyway, thank you for your attention, by the way. Thank you. So now you are on a quest, right? Enable IPv6 when going home.